Hello, dears. Here you have the answer keys and how the questions to solve. And hope the exams was fine. And this questions is mixed of some partly difficult questions and partly easier questions. So we'll have a look into it. First question is: an electric dipole placed in a non-uniform electric field will experience. And that's a direct question. You have the answer C, that is both force and torque. And that is an electric dipole placed in a non-uniform electric field that will experience both force and torque. So the first answer is option C. And the second question is, let N1 be the number of electric field lines going out of an imaginary cube of side A that encloses an isolated point charge 2q, and N2 be the corresponding number for an imaginary sphere of radius A that encloses an isolated point charge 3q. Then N1 by N2 is, you can directly take the ratio, that is what 2 by 3 will be the answer. And that is option B. And in the third question, there, in the circuit given below, P is not equal to R and the reading of the galvanometer is same with switch S open or closed. Then here, if the circuit is open, then the current through this R is equal to current through I. That is IR is equal to IG. In other case, we can take that if the current through this Q is equal to and the current through this G equal, that is IQ is equal to IG, which means both the current that is IR is equal to IG, or in the another situation that IQ is equal to IG. And that is the question number three. And we'll move on to the next question, that is question number four. There, two wires A and B of the same material having length in the ratio 1 is to 2 and diameter in the ratio 2 is to 3 are connected in series with a battery. The ratio of the potential differences, that is VA by VB across the two wires respectively, is that we can have the equation, that is R is equal to rho L by A, where R is the resistance and rho is the resistivity, L is the length and A is the area. And we have I is equal to V divided by R, and in a series connection, that is I is equal to V1 divided by R1. And if we give the value, that is area, we have that is pi R square, and we take that is the diameter, and resistivity will be the same because in the question it is given that the wires are of same material, therefore the resistivity will be equal. So, and consider that situation, that we can write as that is rho 1 divided by pi 4. 4 because of this ratio of the square of the diameter, and here rho into 2 divided by pi 9. And we have V1 divided by R1, we can take the ratio, that is what V1 divided by rho L into pi 4 is 2, that is V2 divided by rho 2 into pi 9. We can write as V1 divided by V2 is equal to, that is 9 by 8. Take the ratio. So that is the answer. We'll move on to the next question. That is, two moving coil galvanometers G1 and G2 have the following particulars respectively. That is, it's given N1 is equal to 30, A1 is equal to 3.6 Newton raised to minus 3 meter square, B1 is equal to 0.25 Tesla, and N2 is 42, A2 is 1.8 Newton raised to minus 3 meter square, and B2 is equal to 0.50 T, that is Tesla. The spring constant is same for both the galvanometers. The ratio of current sensitivities of G1 and G2 is, we have the answer as, that is current sensitivity, that is phi divided by I is equal to NAB divided by K, and here the K is constant, so we can directly substitute this value and we'll get the equation, or we'll get the answer as 5 is to 7. Next question we have, a current I is flowing through the loop as shown in the figure, that is MA is equal to R and MB is equal to 2R. The magnetic field at the center of the loop is mu0 times I divided by R. And when we compare the answer, here we have the equation that is B is equal to mu 0 Ni divided by 2R. In this case, we have to take that B is equal to that is mu 0 Ni by 2R into 2, that is 4 Ni by 2R will get. And the first ring, the 3 by 4 part of this first ring, and in second ring it is 1 by 4. So in second ring we have to add that 2 in the case of the radius, and we can write as that is mu 0 divided by 2r into 3 by 4 plus 1 divided by 8, and simplifying we will get as 7 by 16 into the plane of the paper. And we will have the next question, that is a capacitor and an inductor are connected into different AC circuits with a bulb glowing in each circuit. The bulb glows more brightly when have the answer as option D. That is, a dielectric is introduced into the gap between the plates of the capacitor. That's all direct questions. So directly you can go into the answer. And the next question, 8. A pure inductor of 318 millihenry and a pure resistor of 75 ohm are connected in series to an AC source of 50 Hz. The voltage across 75 ohm resistor is found to be 150 volt. The source voltage is, and we have this L is equal to, that is 318 mH, and resistance 75 ohm, and mu is equal to 50 hertz, and the voltage is 150 volt. We can we have that I is equal to V by R, and that is 150 divided by 75 gives 2 ampere, and we have the XL is equal to 2 pi mu L, and give the value 2 pi into 50 into 3.18 is gives 100 ohm, and in this case the V is twice this 200, and therefore the total voltage is 200. Here this is 2 into 100, which gives 200 volt, and the total voltage is 200 plus the 150, which gives V is equal to 200 volt, since this 2 into 100 gives that 200 volt, and the total voltage is then 250 volt. We have the electric potential at a point on the axis of a short electric dipole at a distance x from the midpoint of dipole, it is proportional to 1 divided by x square. That is the correct question. Let F1 be the magnitude of the force between two small spheres charged to a constant potential in free space, and F2 be the magnitude of the force between them in a medium of dielectric constant K. Then F1 divided by F2 is obviously that is what K. The question is a direct question. Infinity resistance in a resistance box has a gap only. That is option D for the 11th question. And a battery of 15 volt and negligible internal resistance is connected across a 50 ohm resistor. The amount of energy dissipated as heat in the resistor in 1 minute is. And here we have that I is equal to this epsilon divided by R plus R, and we can directly substitute the value 15 divided by 50 gives zero point 0.3, and substitute in joules heat law. We will get as 270 joules. That is option D. Next 13, Lenz's law is the consequence of the law of conservation of energy. 14. The vertical component of Earth's magnetic field at that place is 1 by root 3 times the horizontal component. The angle of dip at that place is tan value, so it is tan 30 degrees. A long straight wire in the horizontal plane carries a current of 15 ampere in north to south direction. The magnitude and direction of magnetic field at a point 2.5 meter east of the wire respectively are. Here we can give the value, that is B is equal to mu 0 to I divided by 4 pi r, and directly substituting this value, that is mu 0 is equal to 4 pi into 10 raised to minus 7 into 2 into 15 divided by 4 pi into 2.5 gives that 1.2 micro Tesla. Next question is, that is here 1.2 micro Tesla vertically upward, option A. The EMF induced in a 10 Henry inductor in which current changes from 11 ampere to 2 ampere in 9 into 10 raised to minus 1 second is. Here, this is epsilon is equal to minus d. Here, this EMF is equal to minus L di by dt. Taking the derivative, we can write this. And also, instead of this, taking the derivative, we can directly substitute like minus 10 into, that is what, 9 divided by 9 into 10 raised to minus 1, which gives the value as 10 square volt. A charge Q is placed at the center of the line joining two charges Q and Q. The system of the three charges will be in equilibrium if Q is. Here at equilibrium net force is 0. So, and we are writing as the direct, or we can directly substitute the value 1 by 4 pi epsilon 0 capital Q divided by R by 2 the whole square plus 1 by 4 pi epsilon 0 Q square divided by R square gives 0. In this condition, uh, substituting the values and calculating, we will get as this 4Q is equal to minus Q, and that is Q is equal to minus Q divided by 4. Next question is electric flux over an electric field vector E through an area dA is given by option C, that is E dot D. Next question. In a potentiometer experiment, the balancing length with a cell is 120 centimeter. When the cell is shunted by a 1 ohm resistance, the balancing length becomes 40 centimeter. The internal resistance of the cell is. Here we can write the equation, that is small letter r, that is internal resistance, is equal to capital R into L1 minus L2 divided by L2. Here R is 1 ohm and L1 is 120 centimeter and it's given L2 is 40 centimeter. Therefore, substituting the value, we will get as this R is equal to 2 ohm. Next question. An electron is projected with velocity v along the axis of a current carrying long solenoid. Which one of the following statements is true? Here it is option D, that is the electron will continue to move with the same velocity v along the axis of the solenoid. And the next question 21, if the speed v of a charged particle moving in the magnetic field B, that is v is perpendicular to B, is half, then the radius of its path will become half. That is 21 is option D. Next question number 22. A metal plate is getting heated. Which one of following statement is incorrect? Here it is option A, that is, it is placed in a space varying magnetic field that does not vary with time. The all other statements are correct. Next question is 23. In an AC circuit, the applied voltage and resultant current are E is equal to E0 sine omega t and I is equal to I0 sine omega t plus pi by 2 respectively. Average power consumed in the circuit is. We can write as this phase difference phi is equal to pi divided by 2. Therefore, power factor cos phi have the value cos pi by 2, which is 0, since cos 90 is 0. And the power is equal to E RMS I RMS cos phi, that is equal to 0. Therefore, the answer is 0. Next question. The speed acquired by a free electron when accelerated from rest through a potential difference of 100 volt is. There we can have the equation, that is V is equal to root of 2qV divided by m, and substituting the value, that is root of 2 into 1.6 into 10 raised to minus 19 into 100 divided by 9 into 10 raised to minus 31, which gives 6 into 10 raised to 6 meter per second. Next, which one of the following is not affected by the presence of a magnetic field? Here it is the option C, a stationary charge. Next question number 26. 2-point charges plus 16q and minus 4q are located at x is equal to 0 and x is equal to n. The location of the point on x-axis at which the resultant electric field due to this charge is 0 is. There, let the electric field be 0 at the point P at a distance x from, that is 16q, and we are taking this is plus 16q here, and we are considering here this is minus 4q and a point P, and this is x is equal to 0 and x is equal to L. And at P, this E1 plus E2 is 0. Or we have this k is 1 by 4 pi epsilon 0, and we are taking the 16q divided by x square plus k into minus 4q divided by x minus L the whole square is equal to 0, and calculating all this or simplifying this equation, we can will get as this x is equal to 2L. Question number 27. An electric dipole of dipole moment 4 into 10 raised to minus 5 coulometer kept in a uniform electric field of 10 raised to minus 3 Newton per coulomb experiences a torque of 2 into 10 raised to minus 8 Newton meter. The angle which the dipole makes with the electric field is. Here, that is, answer is directly we can calculate from this tau is equal to P cross E, or tau is PE sine theta, and see sine theta has the value tau divided by PE, and substituting will get 1 by 2, that is theta is equal to 30 degrees. Next is three identical charges are placed on x-axis from left to right with adjacent charges separated by a distance d. The magnitude of the force on a charge from its nearest neighbor charge is F. Let I cap be the unit vector along plus x-axis. Then the net force on each charge from left to right is. This is the case of the three equilateral, which is placed at the equilateral corners of the triangle. And directly substituting the value, we will get as option C. Next is two students A and B calculate the charge flowing through a circuit. S concludes that 300 coulomb of charge flows in 1 minute. B concludes that 3.125 into 10 raised to 19 electrons flow in 1 second. If the current measured in the circuit is 5 ampere, then the correct calculation is done by both A and B had the correct calculation, since the current is the flow of electrons. The resistances of two wires having same length and same area of cross section are 2 ohm and 8 ohm respectively. If the resistivity of 2 ohm wire is 2.65 into 10 to minus 8 ohm meter, then the resistivity of 8 ohm wire is. There R is equal to rho L by A. Directly substitute the values, you will get the answer as option A. In a certain region, electric field E and magnetic field B are perpendicular to each other. An electron enters the region perpendicular to the direction of both E and B and moves undeflected. The speed of the electron is the case of that velocity selector, that is E by B ratio, and option C. A test charge of 1.6 into 10 raised to minus 19 coulomb is moving with a velocity v, that is given by 4 I cap plus 3 k cap meter per second in a magnetic field B is equal to 3 k cap plus 4 I cap Tesla. The force on this test charge is. There it is the case of Lorentz force, and option D, option that is 0. Next is in a series LCR circuit at resonance, the current is equal to. That case in the resonance circuit 33 gives that is V by R. Next is the frequency of an AC source for which a 10 microfarad capacitor has a reactance of 1000 ohm is. There you have that is XC is equal to 1 by 2 pi nu C, and substituting the value you will get as 50 divided by pi hertz. That is the case of X is equal to 1 by 2 pi nu C. And next 35. In the given network, all capacitors used are identical and each one is of capacitance C. Which of the following is the equivalent capacitance between the points A and B? Taking this parallel and series circuit, the parallel circuit has the value that is C is equal to C1 plus C2, and in series circuit 1 by C is equal to 1 by C1 plus 1 by C2, like that. Giving the value that is in this circuit, we will get as a 3 pi by 2 C. Next question, number 36. The given figure shows IV graph of a copper wire whose length and area of cross section are L and A respectively. The slope of this curve becomes. Here it is option A, less if the length of the wire is increased. Next question 37. When a potential difference V is applied across the conductor at temperature T, the drift velocity of the electrons is proportional to direct question option C. That is proportional to this potential difference V. 38 two identical thick wires and two identical thin wires, all of the same material and the same length, form a square in three different ways P, Q, and R as shown. Due to the current in these loops, the magnetic field at the center of the loop will be zero in case of. That is the case in P and R only. That is option A. Next question we have. A circular current carrying coil produces a magnetic field B0 at its center. The coil is rewound so as to have three turns and the same current is passed through it. The new magnetic field at the center is 39th question. A circular current carrying coil produces a magnetic field B0 at its center. The coil is rewound so as to have three turns and the same current is passed through it. The new magnetic field at the center is. Then 39, that is if R is initial radius, and that we can write as 2 pi r is equal to 3 into 2 pi r1, and that is r1 is equal to r divided by 3, and if this b0 represents the initial value, here h0 I divided by 2r, and b final is can write as this h0 3i divided by 2r1, and uh, here that will be equal to 9h0i divided by 2, that is 9b0. Next, which one of the following statements is true? Here the option D is true. An inductor can conduct in a DC circuit but not a capacitor. Capacitor always block DC, it only conducts AC. 41. The magnetic flux linked with a coil is given by phi is equal to phi t square plus 3t plus 16, where phi is in Webers and t in seconds. The induced EMF in the coil at t is equal to 5 seconds will be. It's 41 question. And this is option A, that is 53 volt. You can directly substitute that it's epsilon is equal to minus 3 divided by dt. Taking the derivative, you will get as 53 volt. If a charge is moved against a coulomb, work is done by the external source. In 43, a charge Q is located at the center of a circle of radius r. The work done in moving a test charge Q0 from point A to point B at opposite ends of diameter AB so as to complete a semicircle is K is equal to 1 by 4 pi epsilon 0, and there it is a case of equipotential surface. That is option D, 0. Next question, number 44. A long solenoid carrying current produces a magnetic field B along its axis. If the number of turns in the solenoid is half and current in it is double, the new magnetic field will be. It is the case of B is equal to mu 0 Ni. And when this N is reducing, that is N by 2, and current is increasing, that is 2I, there is no change in this equation. Therefore, the magnetic field will be B itself. Next question, number 45. This is a different way. Here, both assertion and reason are true. Reason are is the correct explanation of assertion A. Like that, the question is. So, look into the first question. That is 45. A bar magnet experiences a torque when placed in a magnetic field, and its reason is a bar magnet exerts a torque on itself due to its own magnetic field. And here it is. Assertion is true, but the reason is false. Therefore, option C. Next question, number 46. In a series LCR circuit connected to an AC source, resonance can take place. At resonance, XL is equal to XC. Here, both assertion and reasons are true, but the reason is not the correct explanation of the assertion A. Therefore, option B. Next is when a charged particle moves with velocity v in a magnetic field B, the force on the particle does no work. Here, both assertion and reason are true, and reason is the correct explanation of assertion A. And in 48, induced EMF in two coils made of wire of the same length and the same thickness, one of copper and another of aluminum is the same. The current in copper coil is more than the aluminum coil. Here also both assertion and reason are true, and the reason is the correct explanation of the assertion A. And 49. A transformer is used to increase or decrease AC voltage only. A transformer works on the basis of mutual induction. Both assertion and reason are true, and the reason is the correct explanation of assertion A. And in next section C, two charged spheres A and B having their radii in the ratio 1:2 are connected together with a conducting wire. The ratio of the surface charge density is direct question. Directly you can substitute the value, and the ratio is option B, that is 2. Next question 51. A current carrying square loop is suspended in a uniform magnetic field acting in the plane of the loop. If the force on one arm of the loop is F, the net force on the remaining three arms of the loop will be, obviously it is minus F. A battery is a combination of two or more cells. In the following figure, a single battery is represented in which two cells of EMF epsilon 1 and epsilon 2 and internal resistance R1 and R2 respectively are connected. In that case, you have to notice that epsilon 1 is negative terminal is connected to A and the positive terminal is connected to B, and epsilon 2, that is the second battery, the positive is connected to A and the negative is connected to the terminal B. The equivalent EMF of this combination is then, that is option A, epsilon 1 R1 plus epsilon 2 R2 divided by R1 plus R2. And in question number 53, for terminal B to be negative, here this both option B and C are correct. That is epsilon 1 R2 less than epsilon 2 R1, and epsilon 1 R1 is greater than epsilon 2 R2. Next, the current in the internal circuit is, that is epsilon 1 plus epsilon 2 divided by R1 plus R2. And the last question, the equivalent internal resistance of the combination is option C, that is R1 R2 divided by R1 plus R2. This all questions comes from the connection of the cells in series or parallel. In that section, you have the derivation part. The question is related to that section. It was easy, but also some questions are there which is of high standard. And hope you have done your examinations well. And we'll see you with another topic in the next class. Thank you.